Good morning, everybody. We are going to continue with exponential functions, and today we're just going to be graphing, which is not so bad. A lot of calculator, a lot of GeoGebra. So I'm going to start by taking that, just sketching the function 2 to the x. I mean, you guys can go into the calculator and pretty much graph anything you want. So if I do 2, raise it to the x power, you see this exponential function. So it's really important for you guys to see a lot of characteristics about this graph, but I just want to investigate with you for a minute. So you see 2 to the x, okay, and you see this, hopefully, you see this graph increasing. As you work from left to right, just like you read a sentence, okay, this graph is moving and increasing and going up from left to right. So if I look at my table of values, I'm just going to go from -2 to 5. You could see as x increases, as this goes up by 1, the y values are also increasing. Now, it's kind of hard to see with the decimals, but look the whole numbers. From 1, it goes to 2. From 2, it goes to 4. 4 to 8. 8 to 16. 16 to 32. What's happening? It's doubling, right? It's being multiplied by 2. Hence the equation y equals 2 to the x. Your ratio is 2. Your constant ratio is 2, and it's doubling every single time. So I can make that base anything I want. If I want to make it 3 to the x, okay? Look here. It's steeper, right? Does everybody agree? It's now increasing. If I looked at a table of values, look, it's going from 1 to 3, 3 to 9, 9 to 27. It's now not doubling, it's tripling, okay? It's increasing by 3 every single time. Now, I shouldn't say increasing. It's being multiplied by 3 every single time. This is not increasing at a constant rate. It's not linear. It's exponential. I could even make it 5 to the x, okay? And we see it even grow steeper. So this is now increasing at, again, a larger rate, where I shouldn't say the word increasing, but it's growing. Growing is the better word. Okay, so that's all growth, okay? We're seeing that all over the news, right? We're seeing all these crazy exponential graphs increasing. What do we want to start seeing? Something decrease. So what would my base have to be for it to decrease? A lot of people will say, what about 1, right? We went 2, 3, I went up to 5. So if I raise 1 to the x power, okay, exponential, where the exponent has the variable, 1 is not 1 to a power is not an exponential graph. It's actually linear, because when you raise 1 to any power, you always get 1. So really important with exponentials, you can't have a base of 1. How about a base of 0? That's not going to work either. Same thing, not happening. So I'm going to make my number smaller, but I'm not going to make it a negative. I'm going to make it a fraction, like a half. What if I raise 1/2 to the x power? We'll take a look at that. So I'm going to just change that color. What if I make it pink? Similar to the other one, but that's okay. Okay? There you go. Like, there is an exponential that's decreasing. So if I looked at this table of values, right, look what happened here. When I start, it's p of x, and when I start at 4, then it goes to 2, to 1, to a half, to a quarter, to 0.125. You are halving every single time. See that? So your y value is, it's decaying at a rate of a half. I can make it a third, okay, and raise it to a power of x. And you could see that. Okay, so you're seeing all these graphs. So there's a lot of really important things. What point do every single graph, every one of those graphs, what point do they all have in common? Hopefully everybody could see their y-intercept is exactly the same, 0, 1. Something else you're going to notice, I mean, it looks like it, but when you get really close, is this graph ever hitting the y-axis? It's not. Okay, it gets really close to the y-axis, but it's not going to hit it. Okay, so I lost my voice. So if you come back to my standard view, the other way as well. If I get really super close to the x-axis, it's never hitting the x-axis. And we call this, I don't know if you remember, we call this an asymptote. These graphs are asymptotes. They get super close to the x-axis, but they'll never intersect it. Okay, so I'm going to come back to your lesson here, and I'm just going to show you how you're going to graph this. I'm going to set up a table of values. You have to have this table of values. Why? When you're graphing anything other than a linear function, you need a table. I'm going to do it without even looking at my calculator. You could do it with the calculator, but I'm going to just show you. If I'm graphing 2 to the x, and I'm just going to start with, think about 2 to the first power, right? Okay, so 2 to the 1. Okay, that means this. 2 to the first power. What do I get? 2. Okay. 2 to the second power, when x is 2, I get 4. 2 to the third power, when x is 8. 2 to the third, I get 8. Now, I'm not going to go any further because 2 to the fourth power is going to give me 16. So I'm going to go in reverse. 2 to the 0 power, anything to the 0 is 1. And now as I get smaller, -1, we just came off of negative exponents. What happens? I make it 1 over 2 to the first, or just 1/2. -2. 2 to the -2 power would be 1 over 2 squared, or 1/4. So if I graph those, -2 to the fourth, -1 is going to be 1/2. 0 would be 1. 1 goes to 2. 2 goes to 4. And 3 goes to 8. Okay, and this thing is going to keep growing and growing and growing exponentially. So it gets a arrow. Now the crazy thing is, it's also going to keep decreasing exponentially. But the most important thing I could say to you is look at my graph. I will never hit the x-axis. There is an arrow, but I'm never going to let my graph touch the x-axis. There is an asymptote. Okay, right here is what we call an asymptote. Okay, the asymptote is at y equals 0. So here are a bunch of characteristics that you guys need to know. Okay, you're going to see here exactly what I just did. And just notice a couple of things that I could highlight here. Your base, which is b, is always greater than 0. It can't be equal to 1. So remember, your base is either greater than 1 or in between 0 and 1. So a really important thing I could say to you is when you have growth, okay, this is growth. Everybody sees your base is 2. It's growing. That means your base is greater than 1. Any base greater than 1. It could be 1.01. Your base would be growing. Now, when you see decay, decay is not just less than 1 because it can't be 0. When your base is in between 0 and 1, like for example, okay, a base that is 1/2, or a base that is 1/3, or it could be anything. It could be a base of 0.75, okay, where here your base would be examples of 2 or 3, or your base could really be 1.05, okay? So know your different bases of growth and decay. So important characteristics about your graph. Really important, your domain, all real numbers. In other words, this is going to, from left to right, it's going to include everything from negative infinity to positive infinity. Okay? It's going to have a range of not everything from negative infinity to positive infinity. Your range is going to be where everything y is greater than 0. Notice it doesn't include 0. Why does it not include 0? Because it's never touching the x-axis. It's everything greater than 0. Your graph is in quadrants 1 and 2. Okay, 0, 1, which is your y-intercept, okay, lies on the line. It has an asymptote at either the x-axis or y equals 0, and it's a curve that increases or decreases. It is not increasing at a constant rate. An exponential graph, I'm going to write, does not increase at a constant rate, because that would be linear. Okay, this is growing or decaying. So take a look at this graph, and I want you to just be able to tell me right away, this graph is not growing, it's actually decaying. Okay, from left to right, as I move, it is decreasing. Okay, so that means your base can't be greater than 1. It can't be just less than 0, because this would include negatives. So where would your base be? Right here. Everything in between 0 and 1. Fractions. This is all fractions. I shouldn't say all fractions, but fractions that are in between 0 and 1. A half, a third, 3/4. Okay? That would be a decay. So your base in a graph that looks like that would be fractional between 0 and 1. Okay, let's look at some of our transformations. So everybody take a look at this graph that I'm graphing, and notice, look at the base, a half. This base is 1/2 to the x, okay? And they want you to graph on the same set of axes f of x minus 4 plus 2, and we have to remember some of our transformation rules. This rule tells us something, and this rule tells us something. If it's inside parentheses and it's a minus, remember it goes the opposite way. This is moving to the right 4. And if it's outside parentheses and it's a plus, this is moving up 2. So a really easy way, you can't put that in the calculator with just f of x minus 4, x plus 2. You could put it in with the 1/2, but you would have, it's a little bit more difficult. Watch how easy this is going to be to just transform. Take each point, take this point, move it to the right 4, 1, 2, 3, 4, and then up 2. Okay, so I just moved this way and this way. I could do it again with another perfect point. I can move to the right 1, 2, 3, 4, up 2. I can move right 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. Okay, and then you're going to start to see 1, 2, 3, 4, up 2. It's all going to be an asymptote here, so I'm going to sketch my graph. Notice, look what I am not going to do. I am not going to let that graph pass this new asymptote. Right now, I'm going to just sketch for you. Here, right here, is the asymptote of this blue graph, y equals 0. The asymptote, what is the asymptote of the original? So in the f of x, the asymptote is y equals 0, or you could even tell me the x-axis. Does everybody see that? Right where I just sketched this green, there's your asymptote. But the asymptote, that's not the same for the pink graph. Here's your asymptote for the pink graph right here. This graph is never going to hit that line. This line is not at y equals 0 or the x-axis. It's at y equals 2. This asymptote is at y equals 2. So what happened? That's not a coincidence. It was shifted up 2. Your asymptote was shifted up 2. So let's talk domain and range. Well, let's talk about your f of x function first, the blue graph. What's the domain of your blue graph? Your domain is easy. It's always going to be from left to right, all real numbers, negative infinity to positive infinity. And I messed that up because it should always be parentheses. Your range of your blue graph is everything greater than 0. Y is greater than 0. Where your pink graph is going to be a little bit different. Your h of x, okay, your domain, does that graph exist everywhere from left to right? It doesn't look like it, but that's going to keep going and going and going up and right, up and right. That really is going to stretch it out to the left and to the right. It still has a domain from negative infinity to positive infinity. But what's your range? What's changing? Well, your range is no longer everything greater than 0. It's now everything greater than 2. So y is greater than 2. It can't be equal to 2 because it's never going to touch your point at y equals 2. It's everything above it greater than 2. Okay, I'm going to sketch one more with you. So in this one, a little bit more difficult. Now, you could put this in the calculator. It's 2 to the x plus 1. It's in your exponent. See this? It's like it would be in your parentheses. And it's a plus, so just know this is moving left 1. Plus 1 goes left 1. And this is moving minus 3 down 3. Now, I'm going to show you how you're going to graph that right in the calculator. If I bring this up, I'm going to clear all of this out, and I'm going to type 2 to the x plus 1. Notice my x plus 1 is all in the exponent. I'm going to tab out using my little right arrow key, and then I'm going to do minus 3. Okay? And even more important, and I didn't do it, but I'm going to. I'm going to show that I only want to graph this graph from negative 2. So if I do a table of values, I only want to go from negative 2 to positive 2. Okay. So I'm going to set up a little table for myself. I'm going to say, okay, x and f of x. And I have to go negative 2, negative 1, 0, 1, 2. At negative 2, I'm at negative 2.5. I'm at negative 2, negative 1, 1, and 5. Now, really important. I didn't do this when I originally graphed, but I'm just going to show you something. If I did that again and I did 2 to the, in the calculator, in the exponent I should say, x plus 1, and then I tab out and do minus 3, and I want a restricted domain, I'm going to hit a comma, and then I'm going to type in the restricted domain. Negative 2 less than or equal to x less than or equal to positive 2, and then hit enter. Look at my graph. Notice it doesn't keep going. It restricts it only from negative 2 to positive 2. So I just want you to know that this is called a restricted domain. And most important, you don't put arrows. So I'm going to plot at negative 2, negative 2.5. At negative 1, I'm going to negative 2. At 0, oh, I missed that point. Negative 1, negative 2. At 0, I'm down at negative 1. At 1, I'm going up to 1. And at 2, I'm going to 5. And most important thing I could say to you, connect, but don't put arrows and don't go past those 2 points. So explain the transformation. It shifted left 1 and down 3. Okay, and what is the domain and range? Okay, so this is important. Your domain is exactly what they gave you. Here's your domain. -2 less than or equal to x less than or equal to 2. That's your domain. You can't tell me all real numbers. You can't tell me from negative infinity to positive infinity. It doesn't. It goes from -2 to +2. Your range goes from, here's your range, goes from -2.5 to 5, okay? This, I'm going to show, is your range. And on the left side is your domain. Because remember, your domain are your x, your range are your y. So it would be -2.5 less than or equal to x less than or equal to 5. Now, I didn't write it the other way. You guys could have also written domain as bracket -2 comma +2 bracket, and you could write your range as -2.5 comma 5, both brackets, okay? Include both endpoints. I think I'm going to let you do those last 3 on your own. They're just all multiple choice. Be careful. You could do it. Use your calculator and practice. I'll put the answer key up. Okay. See you guys.